Testing, testing, 1, 2, 3, testing, testing. Hello! Testing. There we go. Alright, thank you. That's funny. It's like multiple points of failure, eh? not only was the chat down, but I also had my mic off, so I was removed from the feedback that I would have needed to fix that problem. Or I suppose I could have just paid attention. Anyway, we're here. How are you? I had said basically nothing of consequence, just so you guys are aware. I was commenting on the weather, which seems to be my habit these days. The weather is going to be good, apparently. So, last time when we were talking, we actually got ourselves all the way through our material on graphics and visualization, which is pretty cool. We're motoring. Maybe we will get to cover all of the machine learning stuff. We got a few topics to go, though. Today we've got another kind of bite-sized topic that we'd like to handle. I doubt this one will be an entire lecture, actually. This is about the date-time library. If we finish this one a little early, we can move on to databases, which is a bit beefier. It's a bit meatier. It's got some nice... There's some flesh on those bones. Or I guess if you're a vegetarian, there's some tofu on the popsicle stick. I guess that would be the analogy. Anyway, let's get right into it, shall we? Unless anybody has anything to say, which they don't seem to. Ah! There we go. When A9 will be released. It hasn't been available yet. Ah, poop. Alright. Probably in all of the excitement from the test, it's been overlooked. Alright. Thank you very much. Thank you for letting me know. I'll get that up, and we'll get that out at some point today. Writing that down. Cool. All right. Boom. Post-it note. Kablam. All right. Right. So let's talk about dates. In a previous YouTube stream series, I named the videos slightly funny puns about all of the topics, and I called this video "How to Get Dates," and that triggered all of the nefarious bots from all over the internet to spam my comments section with links to various nefarious websites. So I'm gonna avoid doing that. I'll just tell you the pun. I was going to entitle today's lecture "How to Get Dates," but, you know, at any rate. So, we're talking about dates. Believe it or not, it's actually, like, a reasonably... It's kind of non-trivial to get dates to operate correctly with respect to computer systems, especially in the sort of modern hyper-connected internet world that we live in. It's not too bad. It's just, you know, it requires conscious attention to be able to do things correctly with dates. So, you know, historically speaking, there are a large number of different calendar systems that, you know, were used by various cultures all across this great big blue marble of ours. Gregorian calendars, Bengali calendars, Chinese calendar, Ethiopian calendar, Hebrew calendar, Hindu calendar, Iranian calendar, Islamic calendar, and don't forget the Mayan calendar, even though it just ran out a few years ago. And of course, historically, you also have the Julian calendar. Of course, you know, currently we sort of have this, I don't know, I don't even know what it's called. Is it the Gregorian calendar? I'm not sure. At any rate, I'm pretty sure it's the International Standards Association, or some such body that has completely and wholly standardized time for the entire, you know, rest of the existence of the human race. So we no longer have to fight about how long a month is, for example, which is cool. It means that we can all be very precise about things. within a calendar system, there are many complications. Daylight savings time. That's nobody's quite sure why it exists. I get a different answer each time when I say, "Hey, do you know why daylight savings is a thing?" Nobody quite knows. Everybody has like 3/4 of the truth on that one. Leap years and leap seconds. So, as you may be aware, the period of rotation of the planet Earth around its axis is not an even divisor of the period of rotation of the Earth around the Sun. Therefore, every year you get a certain amount of time that is sort of extra, and we have to put it in somewhere. And it turns out it's round about a quarter of a day every year that we're behind by. So every fourth year we have to introduce a leap year or a leap day to make up the time. The same thing happens on the second scale, actually. It doesn't really matter anymore because everybody's timepiece is more or less calibrated to some kind of central time authority, so you don't really have to worry about setting your watch to leap seconds anymore if that's the sort of thing you were concerned with in the first place. Still interesting to know that it exists. Time zones is the big one. With respect to, sort of the practical side of figuring out what time it is where. You may have noticed, although this has become an increasingly controversial point in recent times, that the Earth upon which we live is spherical, or spheroidal probably, and as a consequence of that, only one side of it can face the sun at any given time. And if you take 2 points, there's sort of subjective impression of what time it is relative to their angle to the sun rather than sort of some objective standard of time measurement. And since it makes a lot of sense for human beings to have time that's measured relative to the diurnal cycle, because we are, of course, diurnal beings, we introduce this concept of time zones. So that, 9 o'clock in the morning in Canada and 9 o'clock in the morning in Portugal or in, Madagascar, wherever, it means the same thing, roughly speaking, for it to be 9 o'clock in the morning anywhere across the globe. Which, is a very useful thing, but it also complicates the timekeeping. The other complication, and this is sort of, this is going sort of down the list of things you have to worry about. The thing you probably most have to worry about on like a technical level is the manner in which your date has been represented. So, when we represent dates inside of a computer system, there are many options. Older computer programming languages will have specific constructs that, specific structures that are composed of integers, and these numbers will be held in integer format. If you move sort of towards the future from there, you start getting lots of string representations because, of course, it's one thing to keep track of time, it's another thing to display time, and in order to display it, you have to have it as a string. And then, of course, you get into object-oriented programming languages, where let me put it this way. Whereas previously, you would have a collection of integers in the form of a structure in something like C, even though you don't know what structure is. It's basically just it's like a class, but with no methods, is a good way to think about it. Those would be composed of integers. Now, we have, of course, date-time objects. We have a date-time class, which has methods, because this is object-oriented, and it makes a lot of sense to bundle these sort of time-related functionalities in with the data over which it's supposed to operate. In general, though, one thing that confuses both people and computers about the manner in which time is kept across the globe is that there are different standards for what goes first when representing the date you know, do you do it year, month, day, month, year, etc., etc. So, if you take a look at this, this is kind of interesting. This is the manner in which date time is standardized across the globe. So, or how dates are written. So, in yellow areas, which is primarily China, Japan, and Iran. I think that's Iran, possibly. These places use year, month, day, so largest to smallest. The sort of overwhelming majority of the planet uses day, month, year, smallest to largest. The United States of America uses month, day, year because of course they do. They're also still, in the imperial system, so although, as I've been aging, I've been developing more of an appreciation for the imperial system. The sort of units that exist in the imperial system are, I think, good sort of working units for quantities. Whereas, when you move to metric, you don't really get like a quart of something being a good quantity of, milk or whatever. But anyway, so the United States is doing its own thing. We've got just a few places in the world who are using both day, month, year, and month, day, year, so the year always at the end, and just a few places in the world that are using both day, month, year, and year, month, day. Of course, Canada is grayed out because in Canada, it is conventional to not have a convention. In Canada, you kind of just use whatever you feel like, and that's how that works. So, and countries that are light gray are countries for which data is not extant. Oh my goodness! Let me zoom back out of that. So yeah, Canadians, we're so accommodating that we'll accommodate pretty much anybody's way of representing dates. So, let me just see if we've got any interesting comments. Are we using the Gregorian calendar? There we go. Cool. Yes. Well, with respect to flat earthism, if I may be permitted a brief interlude, like, I get it, like, if you were to look at the Earth, it does look flat, That being said, if you get in an airplane, like, I don't travel by air very often, but, it is possible to pick out the curvature of the Earth if you're at, 30,000 feet above it, if you're looking for such a thing. So, for anybody who has ideas about the flatness of the Earth, I would recommend taking an airplane. Although I suppose the argument then would be just like every window on every airplane is like a screen that shows you a picture of what you're supposed to see, right? But yeah, like I get it from like a psychological level. But it would be nice if when, like, it's like a form of scientism rather than science, because like the flat earthers claim to be able to demonstrate the flatness of the Earth using experimentation, right? Except whenever an experiment that should succeed or fail whenever they perform an experiment that invalidates their hypothesis, they sort of turn around and invalidate the experiment, which is not how science is supposed to work, incidentally. Although, that's always the temptation. So it's, it's kind of like, it's like science performed by people who do not have a rigorous, scientific epistemology. I'll put it that way. Science as performed by people without rigorous scientific epistemology. But yeah, I don't know. It's if you've ever seen the Flat Earth documentary on Netflix, it's a hoot and a half. Anyway, so talking about Python. when we work with dates and times in Python, we are using the date-time module. Within this module, there are a few different classes, actually. Four, in particular, that you should be aware of, because, those are the useful ones. If you want to represent a date, that is, Gregorian, there we go. If you wish to represent just the date without the time, you use datetime.date. If you wish to represent a time with a time of day without a date, then you use datetime.time. There's also when you declare those, there's also an optional field for time zone, which So if you need to work with time zones, there's stuff built into the datetime classes that allows you to work with time zones easily and convert between different time zones. That's kind of outside the scope of what I would expect you to do, just because, I'm not sure it's that important, but, At any rate, if you wish to have a class or an object that combines both dates and times, then you use datetime.datetime. Relatively straightforwardly. And this is kind of interesting. If you wish to represent the difference between two times, you actually have a separate class for that. It's kind of it makes sense to some degree. It's like if you wish to, add time to, like, if you wanted to see what the time is 3 hours from now, when are you going to make that time relative to, right? It doesn't make sense to add, April 6th at 10:47 to April 6th at 3 hours. Like, it doesn't make sense. So if you wish to perform time arithmetic, we have a special time delta class, which is specifically for representing the differences between datetime objects. And when I say datetime objects, in future, I'm including all three of those. I'm assuming that in your brain you just picked the one you want. Cool. Questions? Oh, any thoughts on Y2K? Wasn't that kind of about dates changing in computers? Yeah, you guys would be too young to remember Y2K now, I think, right? Yeah. So it turned out that Y2K wasn't really a thing. Largely. Although, I guess what I'm trying to say is, everybody thought that Y2K would be the end of human civilization, and it ended up not being the end of human civilization. The original, if I'm sort of throwing my mind back to the year 1999, I believe the, oh my goodness, I was like 11 years old at the time, I think, because I was born in 88. Yeah. So, the explanation was that certain very, 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 very old computer systems were never designed such that they had a sufficient number of memory cells to hold dates higher than, 11:59 on December 31st, 1999. What was anticipated was a so-called what is this called? Not round-off error. Not rollback. Overflow. An overflow error. So, when you have a bit representation of a number that's sort of fixed in length, this doesn't show up in Python because Python gets around it by various mechanisms. But, like, if you have 4 bits, and you got 1, 1, 1, 1, and you add 1 to that, what you end up with is 0, 0, 0, 0. So the idea was that, like, a whole bunch of these really old, important servers that are being used in the internet as it existed in 1999 would suddenly think it was January 1st, 1970, which is the first date of history according to computers. And that would, like, throw off all kinds of tax calculations or, like, mortgage calculations or something. And it's like, first of all, it kind of, the idea that Y2K was going to bring airplanes crashing out of the sky was always nonsense. The idea that, you know, it could, like, it's the type of thing that you could probably have gotten around with manual correction by human beings noticing that numbers are wrong. But essentially, they sort of cracked open these old servers and fixed it before Y2K became a problem. So, although I do remember on my old Compact Presario, which was a 486 machine, that when Y2K hit, I did have to manually set the date, and that was it. So, Y2K. But it was kind of funny because, like, the Y2K scare was quite the thing. You used, like, in sort of the later stages of 1999, you would get software that had printed on its jewel case, because these were CDs that you would buy, right? Software had printed on its jewel case things like Y2K compatible, in the same way that you would have, like, you know, a brand of cereal say it's low sugar. Because, you know, of course the software is Y2K compatible. It's an operating system problem, not a software problem. But there was enough of a craze about it that people could be scared into purchasing software that was specifically labeled as Y2K compatible. So, you know. Anyway, Y2K was fun. Oh, man. Nostalgia. Nostalgia. Anyway. So, let's actually create some date-time objects. Python. Oh, that's my thesis directory. Don't look at that. That's... Oh, man. I should get out of my thesis so I don't do stuff in my thesis. Thesis. Guess who was working on his thesis? Documents. There we go. All right, so from datetime, import datetime. There's a couple of different ways of doing this, right? If you do this, then you can just use datetime, you know, x is equal to datetime. Right. You need positional arguments, though, so let's say 2021, you know, 4, 6. There we go. Oh, right there. There you go. So, you know, you can create objects of the datetime class reasonably easily. The purpose of the import datetime from datetime import datetime, what that does is essentially it puts you in it imports only this one guy, and then that way you don't have to use dot syntax to access the class from the library itself. The alternative to that, if I just quit this guy and reload, there we go. The alternative to that is to just import datetime, which is, you know, a thing that we do with the math library frequently. And in this way, you don't need to know what classes in the datetime library you need up ahead of time. You have access to all of them, but the way that you pay for that is you have to say x is equal to datetime dot datetime. You have to reference the name of the library in order to access the things. Right? 2021 4.6. There we go. Same thing, but you have to use dot syntax. So, just showing you some fun little calculations. X is equal to date datetime.datetime.now. So X is now. Y is datetime.datetime. Initialize it to 2021. April 28th at 9 o'clock in the morning. That is the time of the exam. So, the time of the exam, subtract the time it is currently, means we have 21 day, well, we'll show you how to format this so that it's readable. But I think this is like, I don't know, these numbers are weird. So, anyway, we'll have time to... Wait, maybe if I print it, maybe that'll work. Yeah, there we go. Cool. Print. So the string conversion method for datetime makes it show up like this. So we have 21 days, 22 hours, 4 minutes, 19.344632 seconds remaining between now and the exam. And if you update that, now we have just about, you can see the time is actually decreasing over time. So that's cool. And if you want to, if we print the type of this subtraction, you'll notice that the result is a time delta object, not a date time object. So that's good. There we go. So when you just print a date time object, it prints it in a particular format, right? The date with dashes, year first, sort of in descending order. Everything is in descending order. But, it's possible that somebody may have written things using, the actual names for days, or the actual names for, months or what have you. So we have this function called strftime, which is string format time. And if you apply that method to a datetime object, you can select the manner in which it prints its information. This is kind of an interesting thing. That you do this kind of thing quite often when you're working with C programming. This is one of the few times we see it in this Python course. But if you cast your brain way back to when we were dealing with numerical representation, trying to view all of the decimal points and floating point numbers, we're basically performing the same type of operation. We are taking a value and we are applying a string format to it in order to be able to view it. So, x, there we go. If we do x.string format time, we then provide a string which has tags in it that tell you where to put all of the information. So in this string, any character that's preceded by a percent sign, think of that as a hole into which data will be slotted. So, and the data that will be slotted there is dependent on what the character is. So capital Y is year, lowercase m is month, lowercase d is day, capital H is hour, capital M is minute, and capital S is second. So, if you wanted to say something like, there are, the midterm will be, the day day of month at H minute. The midterm will be on the 6th day of 4 at 10:57. Well, that's actually, it's not true. There we go. So that's cool. There is, if you want to take a look at like a more complete list of these tags, you can get one here. So A is your weekday, for example. Lowercase m is a 0 padded number, but if you want the month as a as the local sort of full name of that month, you do B. So uppercase B. So the midterm will be the 28th day of April at 9 o'clock. So that's cool. You have lots of options. So in the same way, we also have a method that allows us to parse dates from strings. So parse is probably a new term, although I probably mentioned it a couple of times this semester. To parse something means to take it in as text and produce from it data in whatever format that you wish. So in order to execute a program, like a Python script, you must parse the script. You must take the script as represented by a string of characters, and you must interpret it in order to find out, if there are any syntax errors and what the operations are, etc., etc. So parse means read, essentially. So if we wish to parse a string in order to come up with a date-time object, let's just give ourselves a simple example. We have a string 1999 12/31. We wish to interpret this as a date object. So we would do date time dot date dot strp time, so string parse time. Our string, I should have assigned it to a variable, oh well, 12/31. And then we have to include a string which gives us the format of the data. So again, the process is precisely similar to the construction of the formatting string when we are outputting a datetime object. When we are inputting a datetime object, we use the same tags, and we construct it in the same manner. The only difference is that when the arrangements of tags inside of that string will be taken to be a template for the manner in which the first string should be interpreted. So since we know that the first thing is going to be the year, we add the year tag. We then put the slash character in because the slash character is being used. We then use lowercase m, which is date as represented by a number, and lowercase d, which is the day as represented by a number. I think I'll just have to, yeah, cool. So it doesn't work for just date. You have to use a date time to get strp time. So yeah, you can see that it said, okay, year, that's year, okay, good, cool. Month, that's a month, okay. Day, that's a day, fantastic. You can induce errors in this kind of thing. If, for example, we ask for the 31st day of the 14th month, which of course doesn't exist, we get a value error. Time data 1999-14/31 does not match format. So there you go. Cool. Any questions about any of that before we talk a little bit about time zones? Give me a thumbs up. Thumbs up would be good. Okay, nobody's paying attention. I'll just continue then. Oh, there we go. Thank you, Alex. So let's just talk about time zones for a bit. This is kind of like when we talked about XML files at the end of the thing on files. This is FYI, you're not going to be tested on this. So, you have to be careful if you're dealing with dates and times that involve multiple time zones. The Python datetime object can have a time zone set for it, and then it is possible to convert between time zones using the datetime object. The recommended approach is to keep all Python datetime objects in UTC time. That's Universal Coordinated Time, Coordinated Universal Time. Probably that's the French, because the Standards Association, I believe, is in France. But anyway, UTC is your generally accepted international time format, which is is essentially internet time. The way that works is you have it essentially it considers the prime meridian, which passes through Greenwich, England, to be time 0, and for all time zones to be plus or minus a certain number of hours or half hours from that zone. So if you take your local time and you add to it or subtract from it the difference between your time zone and the prime meridian, then you'll get universal time. So the easiest way to do this is to use an external package, PyTZ, to help with time zones. It can also handle daylight savings time, which would be nice. So, from datetime, we import datetime and time delta. We then import PyTimeZone. We create a time zone object by initializing a time zone. You can specify which time zone to use using strings, and if you wish to get a list of all of the different time zones that you can use, then you can just check out the documentation. Easy. Well, it'll be in here anyway, somewhere. So, yeah, anyway. So, you then set up your, set up 2 dates. Why not? Or set up a date. Create a time delta of 1 second. Create an after by adding 1 second to the before. We then have a format string. So that's a cool thing. You can actually save the format string to a variable and then just plop it in to your string format. And if you print these guys before and after, it'll show you the difference. So let me just get it topic 10.5 pi. Throw that in there. Python 3 topic 10.5.py. And there you go. And you can see that it shows you things in this case, we're doing Eastern Standard Time and EDT, which I'm not even sure what that is, actually. Anyway, so Yes, and here's a more complicated example involving a tweet from a particularly recently deposed political person, um, who shall be remaining unnamed. And yeah, so there you go. Date time! Any questions? Perhaps not. Cool. Alright, so let's continue on with databases. So, databases are kind of a different thing entirely. The stuff that we're going to be learning over the course of topic 11, which is like, this is like, I would consider this our last big sort of test coverable topic. So please pay attention. We're going to be talking about relational databases, and we're going to talk about SQL, or Structured Query Language. Now, SQL is it's very different from Python. We're going to be, SQL is in its own right, its own programming language. We're going to be using it in a very, very simplified manner, just to sort of hammer home the conceptual stuff about what a database is and how one might go about accessing one. But yeah, so we should talk about what databases are. Anyway, this is a pretty cool topic. It's databases are pretty interesting and important. So databases then. What is a database, and why would you be interested in them? Well, for one thing, being able to work with a database is a very, very employable skill. It's kind of like database work is a little bit like the accounting. The database worker in the programming world is kind of like the accountant in the financial world. It's like somewhat dry, somewhat routine, but eminently employable because everybody thinks they're too fancy to do, data entry, essentially. That's a quick tip for making your way in the workplace. Never be unwilling to do any work, even if it's tedious or dull, because generally speaking, you only get to do the exciting, non-tedious, non-dull stuff by having done the tedious, dull stuff for a sufficient amount of time. So, a database, a good way of thinking about a database is as a file that has a particular manner of its access. So it's a file that you can't interact with using a text editor, like Gedit or Notepad. In order to interact with the database, you need to go through the database software. Now, there are 100 million different types of database software, which we'll get into a little bit. But generally speaking, we distinguish between sort of the database file itself and the databasing client, the database management system that's used to interact with it. So, yeah, essentially. So, like programming languages, databases allow us to process and store data. However, in a database, data is stored in dedicated files and loaded as needed. Data can be much larger than the available memory, and there is no need to explicitly open files and read data. So, one of the advantages of databases, the thing that databases are designed to do, is to work with very high volumes of data. So, if you think about Twitter or Facebook or YouTube or any of these, social media sites. Take Twitter, for example. Twitter is just a front end for a database. That's like the entire. That's all Twitter is. It's a fancy little it's a fancy front end for a database. That's it. When you tweet a tweet, it gets stored in a database. When that tweet shows up in someone's feed, all that a feed is it's a scanning of the recent database entries. That's all it is, right? It's sort of you whitelist you whitelist tweets by author. That's what following someone is on Twitter. Is you're whitelisting people's tweets by following them, so that when your feed scans the database of recent tweets, it basically composes a they call it a view. It composes a view of the entries in that database that all conform to must have authors this, that, or the other. So, databases are very important and cool. Databases have been designed, like, database technology goes back to the 1970s, and in the 1970s, people were far, far more concerned with sort of robustness. Computers were not considered particularly reliable back in the 1970s. People were often considered more reliable than computers at data processing tasks, so a sort of large amount of effort was being put into computers to make them sufficiently robust that they could be used consistently by people. Because of that fine work, because of all of those old programmers doing God's work in the 70s, we now have computers that actually function decently, and like standards for programming and languages and software, and everything works together because of the 1970s and to some extent the 60s. But anyway, so the way that SQL works is it attempts to maximize the stability of the data inside of the database. It can be accessed simultaneously by multiple clients, either locally or remotely, and when you interact with a database, the database only processes one command at a time from one person. It never, never, never interrupts one command to do another. This is known as atomic operation. Each command is considered an atom. So the effect of that is that you can queue up multiple commands from, all of the people who are tweeting tweets, for example, and the database will never interrupt one to do another, so each one can be reliably said to have operated completely. This means that the database, the data inside of the database is always executed, or it should theoretically always be it should always be correct with respect to the command the last command it's processed. So you sort of have this problem. I think we've talked about this before, but in computer systems, if you have a file that's loaded by more than one person and both people write to it, whoever is the last person to write to it wins, right? Because the first person to write to it has their work overwritten by the second person, right? So this is known as a race condition, because both people are racing to write to it, write to the same file, except in this case, it's the last person who wins. And of course, if both people opened the file at the same time, then all of the changes that person A made will be lost when person B overwrites it. But that's not how databases work. The way databases work is you have the database file, user A sends a command, and let's say both user A and user B open the database, right? User A saves some data to the database. User B saves some data to the database. The database processes user A's save and then processes user B's save. So user A can see updates that user B is making to the database as they are happening. So it's almost like you can think of this file as being continuously reopened every time it changes. But anyway, that's enough talking for today. Oh yeah, can we see the baby? Yeah, let me go grab the little munchkin, and you guys can see him. I'll be right back. There he is. See, he does exist. He's kind of sleepy at the moment. But, yeah. Yep. So this is Felix. Yeah, that's a good angle. He's a baby. He's got a baby face, and he's got little baby hands, and all of the rest of it. So yep. Yeah, I should probably go put him back in his crib now. You see the you see the I think he got my forehead. I do. But yeah. Yeah. So yeah. Again, sorry for taking the time off, but you know, that was kind of a horrible ordeal. But yeah, we were kind of it became obvious that that he was on the way early Wednesday morning, and by 1 a.m. on Thursday, in the middle of the night, I was throwing the bags into the car, and we were heading up to the hospital. It was actually going to be the plan originally was for him to be born at McMaster, but McMaster was actually full up, so we had to sort of make a last minute detour to St. Joseph's in the downtown, which, you know, perfectly serviceable hospital. But yeah, so that was kind of we didn't get very much sleep that night, and by 6:12 in the evening of that day, which was April 1st, he was born, and you know, we stayed overnight at the hospital, and we're on our way home at around 9 o'clock the next day in the evening. So yeah, which was Friday. So yeah. Anyway, yes, he is very cute. Yeah. Anyway, so yeah, that's the kid. Anybody have any questions about anything? How does it feel to be a dad? Feels great, actually. It's like, world better watch out, man, because here I come. That's how I feel right now. Gonna get all the things done. That's what's happening right now. Well, the experience itself is like not a little bit harrowing. It's like one of those things that you read about and like how you think you know how something is supposed to go, and then when it happens, it's like I had no idea. You know, it's really um, being witness to the birth of a child, especially your own, is really nothing like watching the video in health class. You know, um, and it does. I think it does change things fundamentally. But yeah, no, it's like he's definitely a bit of a handful at the moment because he's having to be fed every 2 or 3 hours, like right through the middle of the night. So Allie and I are doing our best to sort of divide the labor with respect to that. But I don't know. I'm finding I'm actually doing pretty well. I don't think I think I may not need as much sleep as I had thought I did all of my life. So because one of the things they say about one of the things that's often said to parents who are expecting children, it's like, oh well, have fun never sleeping again, and it's like, to some extent that's true. At least from what I've read, that sort of is most like things get back to a reasonably normal pace. I think it's about 3 months out. You have to kind of train the kid to sleep at night though, because babies are born with like no concept of what night is. But yeah, no, it's despite the fact that I've been getting, you know, I've been sleeping in basically like 2 hour blocks. Um, Allie's been getting less, of course. Um, I'm doing pretty well. Allie's taking naps in the day, which helps, and we're managing. You know, but yeah, don't if anybody out there is considering the joys of parenthood, I would say don't let the whole not sleeping thing um don't let that phase you. Don't let that be a reason not to, because like it's so amazing to have the little guy that like you're willing to forego many of your sort of habitual comforts, shall we say. But yeah. Anyway, I should probably let you guys go. Um, yeah, cool. All right. Have fun with your classes. See you guys on Tuesday. By which I mean Thursday, because today is Tuesday. See? Time no longer exists.